We can't extinguish the fires. And moreover, it's kind of pointless trying to extinguish fires. We can't. We can extinguish the crisis by using science.
Thank you, everybody out there again for joining us at today's Frontiers Forum. We've got, once again, researchers from all corners of the world, which is just beautiful to see. And we're all here today because we are united by our common mission to make all of science open, so that you as scientists can collaborate better and faster to deliver the solutions that we all need to live healthy lives on a healthy planet. And today's speaker, Mark, represents this mission just beautifully. He's a fire and forest ecologist working on solutions to the wildfire crisis. And as you know, due to climate change, wildfires across the globe are becoming more frequent, they're becoming more extreme, and ever more devastating. Just last year, wildfire smoke for the very first time reached the North Pole. And as we are talking here today, wildfires are actually raging across the United States, with thousands of people being asked to evacuate their homes. Overall, wildfires affect over 6 million people every single year, and they kill billions of animals. And with climate change, it's not going to become any better. To the contrary, it's only going to go worse and worse if nothing is done. So our speaker, Mark Adams, is no stranger to wildfires. He comes from Australia, where I think many of you will still remember the devastating images that we saw in early 2020 before the pandemic started. Mark is a professor of Bioscience and Innovation at Swinburne University of Technology in Melbourne. He's also the recipient of numerous prestigious fellowships and research awards. And we're also very proud to have him as our field chief editor of Frontiers in Forests and Global Change. Mark built Australia's first research centre of excellence to lead bushfire research, where they actually look at how to improve the effectiveness of wildfire management agencies, but as well on how to help communities to manage the risks that come from fire. It is really this focus on both wildfire management as well as working with local communities that you will be seeing throughout this entire talk, but as well the discussions that will follow thereafter. So with that, it is my really great pleasure to now hand the floor to Mark Adams.
It really is a great honor to be here and talking with everyone tonight. Now, I'm in Australia, down under, and I have to put my prop on because we, in the land of fire, are actually in the middle of the coldest start to winter for 30 years. We have record snowfalls in the mountains. They started the ski season a week early, and we've had record rainfall, for the last 6 months on the east coast of Australia. In terms of the land of fire, well, not always. So one of my messages tonight is just that you can have fire and you can have snow in the same place. And that's one of the really important things to understand. So the topic is a fire crisis. And what I would like to do for the next 20 minutes is lead you through some of the history of fire around the world, a few of the major scientific issues, and then try and summarize what is it that we can do in terms of a fire crisis. I can dispense with my woolly hat now that we're underway. The first thing is that the media are telling us over and over again just how bad is the situation. Crisis, calamity, apocalypse, disaster. It's in the media, and just about at any time of the year, you will find fires are causing havoc somewhere in the world. Now, there's no question about the role of fire in the Earth's history, because fires have been in the vegetation record for more than 400 million years. They appeared shortly after the appearance of terrestrial plants, and fires are in the geological record ever after. Fires increased in frequency in hotter and drier periods, decreased in frequency in cooler and wetter periods. But then from 400 million years, if we come forward to 400,000 years ago, we see the real first interaction of hominids with fire. Hominids, the ancestors of humans, had learnt by around about that time that fire was an indispensable part of life. Like it or not, you may as well learn to like it, because without fire, life is very different. If we then jump forward to 40,000 years ago, humans were now using fire routinely. They were using it for heating, cooking, and ecosystem management. Now, what do I mean by ecosystem management? I mean that the indigenous peoples of continents like Australia, Africa, North and South America, large parts of Europe and Asia, indigenous native peoples in these continents were using fire to manage their environment. They'd learnt early that if you have more fire, you can reduce the frequency of woody plants. You can increase the abundance of grasses and herbaceous species. That was a really important piece of knowledge. It was gained early by indigenous peoples, and it's still being practiced today. Now we're going to jump forward a little further to what I'm calling the period of the Great Separation. By the time of the 18th century, large numbers of people, a high proportion of the Earth's population, were now living in towns, in villages, and increasingly in cities. This pattern had been happening for decades and centuries, but it really accelerated in the 18th century with the advent of the Industrial Revolution. As the Industrial Revolution unfolded, people no longer had to burden themselves to go and get the firewood from the forest or the woodland. They could separate themselves from much of the drudgery that was involved previously in keeping warm, in using fire to cook food, and using a range of aspects of fire in terms of transportation. In the 18th century and the Industrial Revolution, there was also the colonial era, which had happened earlier. But the colonial era allowed the people of the old world to use the resources of the new world. Vast amounts of timber were imported to Europe from the new world. Even Australia contributed hardwood timber to London, for example, to pave the streets. But my dichotomy, what I've called the Great Separation, between indigenous native peoples pursuing traditional ways of life and the urban people, is not a pure thing. There's another group of people who are not represented in this dichotomy, and those are the people who live in rural and regional areas and continue to live in rural and regional areas. My dichotomy makes the point at the extremes of native indigenous people, happy to work in forests, happy to live with fire. Urban people regard fire as a threat. But it's the people who live in rural and regional areas who perhaps bear the load of urban ideas imposed from capital cities, who are most affected by the current fire crisis. Now, I'm not going to talk extensively, but I think it's a great topic for further conversation. As I said earlier, I'm from Australia. I'm talking to you from the city of Melbourne, right down there in the bottom of the continent. But what does Australia look like in terms of fire each year? This is a typical fire year, and you can see huge areas that are burnt each and every year in northern and central Australia. Yes, there's fire in the south of the Tropic of Capricorn, where most Australians live in urban settlements. So the north, huge amounts of fire. In the south, lesser amounts of fire, but still there. So Australia is really a good example of the difference between urban and native indigenous uses of fire and living with fire. So there's no fire crisis in Northern Australia. Now, sure, that's got a lot to do with low population densities, but it's also got to do with the knowledge of Indigenous people. The two go hand in hand. But there is, in southern Australia, yes, the capital cities of Perth, Adelaide, Melbourne, Sydney, and Hobart, nearly every summer are at risk of major fires. And once you get outside the capital cities in the southern parts, we've got huge areas of what we call the rural and regional parts of Australia, where people are living near to heavily forested land, woodlands, where fire is commonplace. Those are people who have, either through direct knowledge and direct involvement in fire, learnt how to cope with it. Their big problem is imposition from capital cities of policies and practices that are devised by people who have no experience, a first-hand experience of living with fire. Right, now let's move on and just summarize perhaps where we are today. We've started 400 million years ago. Let's come forward now to 2022. And one of the issues globally is that Indigenous peoples are really struggling to maintain their lifestyle, their livelihoods, struggling to maintain traditional cultures, economic uses of fire. They struggle to maintain access to resources in forests and woodlands that they've had for millennia before. And they very much struggle to be able to control their environment through the use of fire. For example, the maintaining of savanna grasslands in Africa and in Australia is integral to how Indigenous people have lived and would like to live into the future. On the other hand, urban dwellers have really come to see fire solely as a threat. In the United States, for example, Smokey the Bear has been used for decades now, going back in the 50s and 60s. Smokey the Bear was used to tell people who are visiting the rural and regional areas, who are visiting forests and woodlands, to be careful of fire. When you see a fire, put it out. Don't let your campfire keep burning. Now, Smokey was pretty successful as a messenger. And in fact, in the United States, they learned that perhaps he was too successful. The idea that fires should all be extinguished became very much a part of policy. Unfortunately, and it was learnt at some cost, that extinguishing every fire simply makes the problem worse. The fuel that created the fire in the first place continues to accumulate. And so the fire next time is simply hotter and more difficult to control. The United States, though, is also a really good example of how technology can or cannot help us. I've got here a quote from Jerry Williams. Jerry retired as the Director of Fire and Aviation Management for the United States Forest Service about a decade ago. But he, perhaps uniquely in the world, understood just what you can and cannot do in terms of fighting fires. If the United States, with all of its vast resources, helicopters, aeroplanes, satellites, drones, and every other form of technology, if they cannot extinguish the fires, then who can? And Jerry was really upfront about it. And as Jerry said, the traditional approach of just more and more resources directed to fighting fires is run out of road. It's not the way to go. We can't extinguish all the fires. So in 2022, when we think about fires and we ask ourselves the question, is the rate of change in climate creating an existential threat? My answer is qualified, but it is quite clear to me that it's not necessarily the case that we're going to be wiped out by wildfires. Not if we recognise history, not if we recognise that technology alone won't solve it, not if we understand that there's not a perfect solution, and nor if we don't understand that the changes in fire regimes are completely tied to changes in climate. This is enforced by the lessons of history. The geological timescale shows that you get more fire when it's hotter and drier, less fire when it's colder and wetter. And it's certainly the case that the existential threat posed by fire can be mitigated, but we have to use all knowledge, not just a part of knowledge that says you can build a bigger aeroplane or get another satellite. We've got to use the knowledge of Indigenous people and the knowledge that they acquired over tens of thousands of years. Now, in the next few minutes, I'm just going to dip into a couple of the features of science, of current scientific research that really underpin our knowledge of fire today and what's driving it and what might we be able to do about it. The first thing, and this is something that I think most people intuitively understand, that the changing climate, which is due to the rise in greenhouse gases in the atmosphere, is in the first instance reflected in a change in temperature, air temperatures. But air temperatures have only risen by a degree or two. One of the key issues for fire is that the change in air temperature changes the humidity, changes the amount of water vapor that the atmosphere can hold. In this graph, you've got air temperature on the x-axis. We have what we call the vapor pressure, which is the amount of water, in the y-axis. The maximum amount of water that the atmosphere can hold is shown in the green line. The amount that's actually held is shown in the red line. The difference between those two is what we call the vapor pressure deficit. What this graph means is that as temperature rises, the vapor pressure deficit, which is the amount of water that the amount of extra water that the atmosphere can hold, that's increasing. It's like saying that the size of the sponge has increased. Every change in temperature, every increase in temperature increases the size of the sponge in the atmosphere. So the atmosphere in parts of the world has been getting drier. The sponge has gotten bigger, but not everywhere. But when we look at a global map, for example, over a 100-year timescale from 1901 to 2017, the atmosphere has in fact got drier over large parts of northern Africa, parts of central Australia, west coast of the United States, parts of the southern Amazon, Asia, the Middle East. But then there's parts of the world where the atmosphere has actually got wetter. Northern Australia, west coast of South America, eastern United States and southeastern Canada, lots of places in the Congo. So the changes in atmospheric water content and changes in the evaporative power of the atmosphere are not universal. They're highly asymmetric. Now, these changes in the atmosphere are also being mirrored by changes in the vegetation. The same driver, the rise in CO2 in the atmosphere, is causing plants to change in their use of water. This graph shows you what we've called the water use efficiency over the same period as the previous graph of vapor pressure deficit. So over the 100-year period, every decade, we have seen an increase in water use efficiency in the world's forests. Every decade. The bars in this graph are the change in water use efficiency per decade. And you can see that in 2 decades, the Great Depression decade and the decade immediately following World War II, were the greatest increases in water use efficiency. They were the 2 decades of the least increase in CO2. But every decade, we see an increase. So the trees in the forests have been conserving water. They're using less water for their growth and to take up carbon. Now, these 2 features, the change in the atmosphere and the change in the vegetation use of water, are just part of our global efforts to model climate. The increase in water use efficiency, for example, is called physiological forcing. And all of the world's current models, the best models we have to predict climate in future, include physiological forcing. The crux of the issue of physiological forcing is that if the trees are using less water, that means there's more water in soils and more runoff. This was published in an important paper about 13 years ago. But if the trees are using more water, using less water, that means that there's less water to come back as rainfall. And so in parts of the Amazon, we're seeing reduced rainfall. In other parts of the Amazon, we're seeing more rainfall. Now, this is simply a feature of climate at local and then up to regional scales. But the important message here is that the trees in the forests affect the climate themselves in the same way as the atmosphere responds to changes in temperature. But these 2 forces, a drier atmosphere and reduced transpiration by trees, are effectively opposing forces when it comes to the fine fuel, the litter layer that sits on the surface of the soil in forests. If the atmosphere is drier, then you would argue that perhaps the litter layer will be drier, as might be the understory vegetation. But if the overstory trees are using less water, that means the soil is wetter. And by rights, the litter layer should be wetter. And again, the understory shrubs should have more water in them. So these are opposing ideas when it comes to the litter layer, which is one of the most important elements in terms of the flammability of forests. Now, this conundrum, or paradox, can't be resolved at the present time. We don't know which of these 2 forces, the drier atmosphere or the trees using less water, is going to prevail. Will the litter be wetter? Will it be drier? Or can it be both? And that's perhaps what's happening. That in fact, you can have both. You can have at certain times of the year, the litter layer can be drier and the shrubs can be drier and the forest can be more flammable as a result of changing climate. The same litter layer, the same shrubs could be wetter at other parts of the year, also as a result of changing climates. But these are really important questions that need to be resolved. My third example is that we have to use models to try and make predictions. Now, I think everybody in the audience will have a view about models and how good they are and what we should do about them. I'm just going to give you a simple example from Australia. On this graph, we have on the x-axis, it's the number of years since the last fire, from 0 to 80 years. On the y-axis is the fine fuel load, that litter layer that I spoke about. The dashed lines are the modelled equilibrium fuel loads that would be reached within 10 or 20 years of the previous fire. Now, that's the model predictions for fuel load. And there's the data for those same 5 forests. As you can probably quickly determine, it's not necessarily the case that our models are doing a great job of predicting the fuel load. Now, again, this is an area of science where we have considerable uncertainty. But when it comes to fuels, that's one of the very few things that we can do in the short term. In other words, we can actually make a difference by modifying fuels in the short term. We are going to struggle to change the trajectory of climate in the short term. If we stopped all CO2 emissions tomorrow, we would still see ongoing climate change for decades, and possibly for centuries. But where do we need to go? The first thing is, I think, to say it's great to have lots of nice maps showing the current fire activity. It's great to be able to see them. It's easily done. But we don't really need more catalogues of fire activity. We need one, for sure. Let's get a good one, but we don't need dozens of them. We certainly don't need more studies that ignore fundamental properties of fire. Fires, in some ways, are simple: oxygen, fuel, and ignition. 3 elements. But if you're trying to think about, well, what can we do to manage fires, those are 3 things. And we're not going to do anything about oxygen, and we're not going to do much about lightning strikes. Leaves us with 1. And the third thing we don't really need are weakly based models. On the other hand, we will need to re-establish some of the critical elements of fire research that are very hard to maintain, or have been hard to maintain here in Australia, and I know in the US and parts of Europe. It's been very difficult to maintain research that they call physical fire research, the understanding of how combustion works and how fires spread. That's not an easy field, needs to be refreshed. We absolutely have to try and get a better understanding of what I've called fine-grained fire risks within overall climate envelopes. It's only at local and regional scales can we really start to make a difference. And to make the difference, you've got to understand the risks at local and regional scales. Yeah. And the third thing that I'm very passionate about is that we need to bring together the knowledge that Indigenous peoples have had for millennia and bring that much more to the fore in our thinking about how we manage land and forest, or particularly forest and woodland around the world. And I think also in a talk like this, it's really important to highlight what I've called 5 rules. And these go straight to Kamila's comments that the research has to be rigorous. It's got to be open, transparent, and well communicated, soundly based, multidisciplinary. And the 5th point, targeted to solutions. It's so easy to do lots of research that will quantify the problem. Try doing the research that's focused on solutions for a change. Now, I started the talk, and the title of the talk is about extinguishing the fire crisis. I want to leave you with a message, and my message is easy. We can't extinguish the fires. And moreover, it's kind of pointless trying to extinguish fires. We can't. We can extinguish the crisis by using science. And thank you.
Thank you, Mark. Thank you very much for this really inspiring presentation. So look, Mark, I have a whole series of questions. This idea of complexity is something which I think is well, I hope you have the time to get back to it and talk about the role of modeling. And you really have to be a plant physiologist, an atmospheric scientist. You know, more than the woolly cap, you have other hats that you have to wear in order to get to the bottom of this very complex problem. But I want to go straight to the panelists. We have three great panelists with us today, and we're going to start right away. I'm really thrilled to be able to introduce Michelle Mack, who is a professor of ecosystem ecology at Northern Arizona University in the U.S. She's actually joining us from Alaska, where she's conducting fieldwork. And if I understand, she can actually see some fires burning from the window in the room where she's currently sitting. It's the middle of the night in Alaska, so we're very, very grateful that Michelle could join us for the presentation today. And then we have the second panelist is going to be Sunita Narain, who is director of the Center of Science and Environment. She's based in New Delhi in India. And the third panelist will be Doreen Robinson from Nairobi, who is the head of biodiversity and land use at the United Nations Environmental Program. So really a terrific lineup of panelists. So with the questions, we're going to, as I said, we're going to start with Michelle. So Michelle, you're working on boreal ecosystems, and Mark was talking a lot about sort of non-intuitive effects in this space. And your research is also kind of focused on the complexity and some of these non-intuitive effects of these complex ecosystems. Tell us a little bit about that, and where are the big question marks still in this line of research as far as you're concerned?
Well, let's see. I think the big question marks focus on two aspects of Arctic and boreal ecosystems. And the first one is our organic soils, and you're probably all familiar with peat, but increased burning of organic soils. And then the second issue has to do with destabilizing permafrost, or permanently frozen soils, many of which have been frozen since the Pleistocene. And you probably all know that in boreal forest, fires have been part of the historic disturbance regime, but we're seeing an increase in the frequency, the size, the intensity, and the depth of burning. In these ecosystems, the main fuel isn't necessarily the trees or plant material, but it's the accumulated dead plant material in these peat layers. And so one of the things we're really interested in understanding is how this legacy of past ecosystems is responding to fire. You can imagine historically, peat accumulates in between fires, and then it burns during fires. But with more fire on the landscape, we're seeing that this historic legacy is being lost to the atmosphere. And so this is an effect that could really rapidly shift ecosystems from being the historic carbon sink that boreal forest and Arctic tundra have been, to being a carbon source to the atmosphere. The second thing is that these peat layers insulate frozen soils, and they keep them cooler than they would be if they were in equilibrium with current climate. And so what we're seeing is that as fires are burning more of the landscape, permafrost soils are being destabilized. So increasing fire is something that could actually accelerate what we think of as the permafrost carbon feedback to climate. So more warming, more fire, more thaw of permafrost soils, release of carbon as greenhouse gases, leading to more warming. So I think those are two of the major areas where increasing fire on the landscape is a critical question for understanding the global carbon cycle and feedbacks between these ecosystems and climate.
So I'm just going to follow up. So we'll try to connect the two geographical areas, the boreal forests with Australia. On the global scale, are you worried either at short-term, long-term effects of these fires on climate change?
Yes. So everyone's probably aware that Arctic and boreal ecosystems in the high northern latitudes are warming more than twice as fast as average air temperatures on Earth. And as these ecosystems warm, there are big changes occurring that could really accelerate climate change, mainly because they store so much carbon. So, we've paid a lot of attention to just warming soils and thawing soils, but fire is punctuated a really rapid release of carbon to the atmosphere. And so more fire is going to release more carbon until we get back into some sort of Earth system equilibrium. So there's enough carbon in permafrost soils. Well, there's more than twice the amount of carbon in permafrost soils than there is in the atmosphere. So relatively small changes in these carbon pools that might be driven by fire and increased thaw, those could have large effects on the atmosphere.
Michelle, thank you so very much. Stay put. There are going to be questions from the audience in a few minutes. But now we're going to go over to Sunita. Sunita, Mark is very, very concerned about regional populations, about local populations, and how they play a role in this complex system. Two keywords: self-sufficiency and adaptation of these communities. How do you think? How should we be involved in decision making around fire use and fire management at that level, in terms of adaptation, for example, self-sufficiency of local communities?
Thank you, Fred. And firstly, thank you, Mark. I think fascinating, Mark. And more than that, the perspective that I think that Fred has also asked me this question, we really need when we talk about climate change, we talk about fires, we talk about conservation, we need now to really talk about local communities. In your case, you're talking about indigenous communities. From our context, it's really people living in the forests, in what you would call wildlands. For us, they are habitats of people as much as they're habitats of animals. And this is where, Fred, the big challenges, which Mark has talked about so well, is local communities have lived by utilizing the benefits of fires. I mean, in all of the eastern parts of India, along many parts of Southeast Asia, you've had a very, very robust tradition of shifting cultivation. And shifting cultivation is nothing but use of fire to increase the productivity of the soil in lands where you have very high rainfall and therefore very poor soil fertility. The problem has become population pressure, and as a result of it, you've had a change in regime where the system has become unsustainable. But the very idea of using fire to increase soil fertility is not a bad one. The other thing that we are very clear about, and I think that plays a very central role, and I think needs to be brought into policy as we move ahead, particularly when it comes to biodiversity, conservation policy, as well as climate change and resilience, is the role of local communities in being managers of their environments. For too long, we have made local communities as the biotic pressure, as communities who need to be kept out of wilderness forest areas. And we have done conservation without people. And we have believed that that has been a successful model. But today, when we are relooking at biodiversity, relooking at the idea of the new framework for biodiversity, and looking at the challenges of climate change, the existential threat of climate change, the extreme heat in our part of the world, the lack of moisture in our soils, the increased incidences of fires, that we are seeing across my region as well, as much as what Mark said. You need to make communities once again major partners in the management of natural resources. There is more and more evidence coming out of our world to show how when communities were involved in fire management, forest fires were kept under control. And that in spite of all the efforts of the departments, the government departments, the technology at hand, and Mark said that so brilliantly, that technology has huge limitations. And if that is the case in very rich countries of the United States, please consider countries like ours, where resources are also stretched and scarce. So I think, once again, thank you, Mark. Fascinating and really important issues that you have raised, which need to feed into the conservation debate as we move ahead, as much as on climate change.
Sunita, based on what you just said, there's another word I think that comes through very, very powerfully, and that's the word justice. And I think that you're talking about how climate change affects every country differently. So it won't be a level playing field somehow. How do we build a climate resilient world together? And I know, Mark, sorry I cut you off. You wanted to have something to say too. Good.
I mean, Fred, that's a $1 zillion question. I'm speaking to you from Delhi. We've had 3 months of the most intense heat wave. 3 months. It's like a furnace. Now, people like me, we are still relatively well off. We have access to electricity. We live in cooler homes. But just think of the millions in my country who are working out there in the heat, who are being forced to deal with this. And this is clearly attributed to climate change. So there is no doubt, Fred, and I think the world and all of us should be very clear, the poor are victims of climate change today. They are not the cause of the stock of greenhouse gases in the atmosphere. But your question is, what do we do? And I think that's really the big challenge as we move ahead. I think one of the big issues that I can see that Mark has brought out today, which is one of the parts of climate justice, is to also build the resilience of local communities so that they can actually work and cope with the adversity as it happens. Now, the biggest challenge for us, and I think that's where, that's what I take back from Mark, is that instead of being extremely arrogant about our understanding of modern science and our ability to be able to teach them what to do, I think what adaptation and resilience will mean is to listen to them and to invest in the systems that they had and in the knowledge they had and in building on it. And I think that's what we don't see enough of, because in the name of adaptation, you're seeing smart agriculture and all sorts of other sort of fancy language that is coming in. And I can tell you that will only make our part of the world, the poor in our world, even more debt-ridden, even more vulnerable, even more locked into a highly risky system. Now, what climate justice, therefore, tells us is listen and then act, and listen to the voiceless, powerless, and the people whose knowledge we have negated for so long. Listen to them and be humble about it.
Thank you so very much, Sunita. Mark.
Yeah, look, I think the word justice is a good one. I've watched hundreds of hours of video footage of interviews of people in the aftermath of fire. Okay, and almost to a person, they do not understand. They feel hugely unjust. Why me? What did I do to deserve to have my house burnt down, to have my livelihood taken away? And then you amplify that by people who are living in rural and regional areas, indigenous people, or as Sunita said, just the people who have to live there, in the middle of the forest. They're living in the forest, and then someone comes along and said, look, you can't do that anymore. You can't live with fire. We're not going to let you burn here in order to improve your soil fertility. That just creates this sense of injustice that is absolutely pervasive in this subject area.
Thanks, Mark. And maybe we'll have a little bit of time to touch upon that again in the end. But I'd really like to give the floor to Doreen, who got up very, very early this morning to join us. So welcome, Doreen. The question I have for you has to do with, again, a very human question. Our balance with nature, trying to reestablish a balance with nature. From Nairobi, you're very familiar with the African context. Respective diversity, reestablishing an appropriate balance with nature. How does that resonate with you in terms of what needs to happen?
Thank you. Yeah, so I'm going to answer your question by, without a doubt, we're out of kilter in our relationship with nature. But I think part of understanding the fire issue is also how we collectively frame the problem. So we've heard a lot about how wildfires is about forests, and we heard a little bit about boreal, but it's not just about forests. Even peatlands, not just boreal peatlands. I mean, we know that the peatlands in Brazil and Indonesia, respectively, the burning of those have increased and almost doubled their carbon emissions, right? We know that wildfires aren't just about climate. We just started to talk about biodiversity. We know that the changing fire regimes are affecting in deserts, for example. I think the statistic is somewhere around 7-8% of species are threatened, all the way up to savannas, it's around almost 30%. And biodiversity isn't just species. Biodiversity is medicine, food, and services provided for life on Earth. Wildfires are not just an environmental issue. We haven't talked about the health risks, right? But they contribute to air pollution. 7 million people a year die from air pollution on this planet, from some complication of it. And then wildfires are not just a threat. We've heard all about the opportunities, right? Fire provides in terms of indigenous people, ecosystem services. So for me, that recalibration of that relationship with nature is also about defining the problem systemically, holistically, and then looking for those systemic and holistic solutions. And someone asked the question in the chat, I was kind of trying to multitask and try, about human population growth. But the reality is the major drivers of all of these existential threats to life on this planet are driven by human. It's anthropogenic pressure and how we interact with our environment. So until we change human behavior and human use and include humans in those solution finding, we're not going to be able to find solutions.
So just to follow up on that, so you talk about the 7 million deaths a year, the link to the problem, the importance of collectively finding solutions together. What is the role of governments, other policy stakeholders? What type of policy? How should we go about this on the policy level?
So, gosh, another $1 zillion question. Yeah. But I think a couple of areas. First is, UNEP produced a report called "Spreading Like Wildfire," and it looked at, first of all, policy interventions for fire. And the reality is about half of spending for fires is about response. The amount for prevention is absolutely negligible. So first of all, we have to shift how we think about the problem. And so part of policy looking at prevention and planning is critical. The second, we talked a lot, I won't repeat, about the role of communities. And having them as front lines, kind of part of the solution setting, and having them involved in the policy setting. And that takes me really to making sure that our policies are science and evidence-based. Policy is inherently a socially mediated process. Too often it becomes a politically mediated process, but it is socially mediated, which means we need to bring in the social aspects. That means bringing in the traditional knowledge, bringing in the multi-sectoral science-based knowledge, and bringing in the kind of full cost, full value accounting of the problem we're trying to solve, and then having a socially mediated response. And I think the last one is looking for these systems opportunities. I frame the fire problem as not just an environment problem, because there are also some opportunities there. If we frame it as a health problem, all of a sudden there's opportunities that open up of bringing in a different suite of policy tools, One Health kind of dimensions of policy tools and responses that might actually help to systemically get at the problem.
Thank you so very much for that contribution. I think it's a fantastic way to kind of tie some of the leitmotifs we've been hearing about today together, about the fact that we have to be more community focused, that we need a mindset change. I think something that we've all agree upon, and we have to be guided by science. And I think that's one of the reasons why we're here at the Frontiers Forum. And it's just a outstanding high level discussion. Thank you all for your insights. And we're going to just try to squeeze in a couple of questions from the audience. So I know that a few people have a question. If you have, continue to send them along, and I'll start calling on people to pose questions to the panelists. So the question is about the use of artificial intelligence and other high-level informatic approaches in terms of getting a handle on the problem. I don't know, Mark, you talked about maybe this is a chance for you to get a word in about modeling.
Yeah, look, I very much appreciate the question, and I've had quite a lot of people, since this forum was announced, write to me and more or less state the same viewpoint. The fantastic things that can be done with AI, no doubt, machine learning, there's lots of things. The tricky part is getting it focused. As Doreen just mentioned a little while ago, we spend vast amounts on suppression and virtually nothing on the mitigation, on the preparation, making communities resilient, dealing with all of the peripheral. And this goes to your question, Fred, about a complex system. It is complex, and AI is one of those things that can help us identify key intersections of different forces. So, for example, people living in a forest, and if you've got people who live in a forest, they're the first person you should be asking about how to manage the forest, not the last person. But using AI, you can feed in all of these different drivers and help to identify which are the ones, what are the critical intersections of, say, ecology and people, or in Australia, water is almost overwhelmingly our most valuable resource. Fires change the water yield. So why aren't we worried about that? There's so many applications for AI beyond just firefighting that I think and that's my response to these questions is, yes, apply it, but not just to firefighting.
Okay, thanks, Mark. And moving right along, we're going to go to the second question. Patrick Kinney has a question for the panel. Patrick, would you like to remember to say a quick word about where you're from, your institution, and a little bit, maybe just a word about which area of research you work in, please.
Hi, thank you, Fred. This is Patrick Kinney. I'm a professor of environmental health at Boston University and work on air pollution and health. And so thank you, Mark, for the really stimulating talk. I found it very provocative, and it definitely challenged some of my simplistic notions about wildfire and air temperature and dryness and all those things. My question is really from an air pollution side. When I saw your picture of the traditional workers in the fields working with fire, of course, I thought about the air pollution that they were breathing. And I wonder, I know Australia has air quality standards as we do in the United States. And, I could see that those could come into conflict with taking a more traditional approach towards fire, which is going to produce, a fair amount of air pollution and cause exposure. So how do you think about the trade-offs between kind of our modern thinking about environmental control and yet still allowing for traditional approaches towards something like fire that affects air quality? Thank you.
I'm happy to talk, but I'd have other people have got as much idea about this. Air pollution is really at the forefront of a lot of policy discussions in Australia. I think you're probably aware. And for example, mitigation, managing fuels by burning them in the off season, attracts a lot of negative publicity and negative comment precisely because people who have health conditions are not just affected in the fire season, they're now being affected, for the rest of the year as well. There's so many difficulties, if you like, and again, I'll come back to the point about this is a human problem. It's a human problem. We don't have a fire crisis where we don't have people, but we do have a problem where we do have people, and I would like to think that our future policies will be people-centric as much as they are, because we've got to think about the planet. As Michelle was saying, fires in the wrong place can double the amount of CO2 in the atmosphere. And then it won't matter too much whether someone, with an asthmatic condition in Boston or in Melbourne, if we let climate change completely out of get completely out of hand. So we've got to balance the people and the environment. Sorry, that's enough.
Yeah, Doreen, I know that Sunita would also like to say a word about this, but Doreen, why don't you start, please?
Yeah, no, one of the things that I wanted to emphasize also, because you talked about, Patrick, the concept of trade-offs, and I think these trade-offs also are best handled when you work through these multi-sectoral approaches to policy responses, right? The pollution people sit in their bubble, and the fire people sit in their bubble, and the health people sit here, and these bubbles don't come together. So I think the importance is really about having these policy dialogues and using the science we just talked about, scenarios, modeling, but bringing in those multi-sectoral dimensions into those dialogues. And the first and foremost, I do a lot of work on One Health, which is bringing human, animal, and environment together. And the first thing there is developing a common framing of the problem, understanding the potential implications of policy responses outside of your sphere, and then negotiating that together. But I don't think anyone in any country anywhere does that well enough.
And Sunita, would you like to contribute? You're muted, Sunita.
Yes, just a short point. So I don't think, Patrick, anyone is talking about living with fire. I think we're talking about managing fire better. And we are talking about how local communities have learned to manage fire. Clearly air pollution is an issue, but air pollution is an issue exactly as Mark said, where people live. When we have forest fires in the Himalayas, we don't have an air pollution problem as much as a problem of CO2 going into the atmosphere, and as well as degradation of biodiversity and forest resources. Whereas when the farmers are burning crop residue in Punjab, and the winds are bringing that fire to polluted areas of northern India or Pakistan, then you definitely have a pollution problem. But you also have to understand that the world's most wicked problem still today is the millions of women who still cook food using biomass, and they cook it on fire. So, and they're the ones who are suffering the most pollution. So we should always keep that perspective in mind when we talk about all this.
Thank you, Sunita. And we're going to take one last question, and this one is for Michelle. And Jasvinder Sandhu. Jasvinder, would you like to ask your question, please? And just say a word about yourself, the type of research, your institution, etc., please.
My question was related to how to create fire lines if we have some species of bushes and trees which are fire resistant. I have read that in Earth Shastra by one of our old guys, That's about 2,500 years ago, he wrote that for making bridges, we can use date palm trees, stems, which are less, they're not prone to fires. So can we use those kind of genes to create our new plants by genetic engineering and for creating fire lines, so that we can control burning fires to a level which may be possible, and it can help us.
Yeah, I think this is a great opportunity for people who work on plants, plant ecologists and fire scientists and indigenous people to work together to think about creating fire adapted plant communities, either novel communities of plants, that we haven't historically seen, or maybe a return to historically fire maintained plant communities. One thing that we're seeing in the boreal forests of North America is that more fire on the landscape is causing forests to shift from conifers like spruces and pines to deciduous trees, birch and aspen. And we know that these deciduous trees, well, they really like severely burned soils, those organic soils that I was talking about earlier. And these new forests have characteristics that make them different than the historic conifer forests. They store more carbon because they cycle nutrients more quickly. They have a higher albedo, so they reflect a larger proportion of incoming radiation, and they cool the local atmosphere. They provide different ecosystem services to humans, and things like forage for game animals, more berries. And then I think the most important thing is that these deciduous forests are less flammable than coniferous forests. So, there's a natural movement towards more deciduous forests that could break that positive feedback between climate and fire. But we've been working with local communities to really focus in on areas around those communities where wildfire risk is high, and it's partially high because of fire suppression, just in directly around human habitations. And we believe that sort of directed succession or active transition from conifer to deciduous forests in these areas could really reduce wildfire risk. So we're thinking of these as living field breaks, using ecological design and native knowledge to create field breaks that will persist in time, that will provide services to people in the area, and that will reduce the risk for warmer decades to come. So I'm really intrigued by thinking about this idea in other places, like in Australia or in Africa or parts of India, thinking about how we can use ecological design and local knowledge to create less flammable vegetation.
The problem is incredibly interdisciplinary. It brings in elements from all areas of Earth system science. And so look, I would like to wrap up the discussion today. I would like to give each of the panelists and Mark 30 seconds for an insight, an important insight. So I think we'll start with Sunita. Would you like just a high level insight, one last message for our audience today, please?
Clearly, Fred, that in today's age of climate-risked world, we need a new ethic of conservation. And I think that's going to be the way we'll have to move ahead.
Thank you, Sunita. And Doreen.
Yeah, I'll just reiterate the importance of inclusivity in decision-making and solving problems together.
Okay, thank you. And and then we'll just go to Michelle.
I was really struck by the slide that Mark showed of the distribution of fires in Australia, and it just brought home to me the fact that we can look to places where fire is used, has been used historically by humans, and where fire is more frequent, to thinking about the future for areas where fire has been less frequent, and thinking about adaptation and change.
Yeah, I agree entirely, and that's the power of data, presentation. I think that was an incredible insight. I agree 100%. Okay, Mark, for you, you get the last word.
Yeah, look, I'm going to do the reciprocal and say I think Michelle's description of local communities working with their environment, their plant species, and then trying to think about ways, intelligent design. And this is where, artificial intelligence, it's where the community, it's where the policy, it all comes together in local settings. And I think for me, that's critical.
Yeah, thank you very much, Mark. I think that's an excellent way to wrap up our panel presentation today. So we're at the end of the session, and thank you to all of our participants, to the speaker, Mark Adams, as well as Michelle Mack, Sunita Narain, and Doreen Robinson. Thank you all very much for your contributions today. It was an outstanding discussion. And thank you to everybody out there who attended today's meeting. I think we reached about 1.5 thousand people at the peak, which is fantastic. We look forward to seeing you all at the next Frontiers Forum session. So keep an eye out for the information that will be coming soon. And just a quick reminder that you can continue the discussion about today's session on social media using the hashtag Frontiers Forum. So until we gather again for the next Frontiers Forum, a warm goodbye to everybody.
Bye. Thank you.
Goodbye.
Thanks a lot. Bye-bye.
Goodbye, everybody. Thank you for joining us.